All right, class. Sorry I wasn't there today. Um, Looked like it was a little bit of food poisoning. Just some food did not really like me. So I wanted to go over a couple of things that I heard some questions on. So on page two, I heard people are having really trouble with this problem here. It wasn't supposed to be a big problem, but for some reason it was a problem. What you need to do is you need to get the data. So here's the data. You just need to copy this data. So you just have to do a copy and paste to get the data. And then you have to dismiss that and then just paste the data in here. These are the hours that people were sleeping. So we could change this. This is just hours. I had my students ask how many hours they slept last night. So I just wanted you to very quickly be able to see everything, the summary statistics, the histogram, and the box plot, and then answer some questions about it. So I think that should help you be able to do this problem. There really wasn't too much to it. I was just hoping you would notice, you know, and maybe you want to change the bin width. I don't know. You could change the bin width to like a half. I wanted you to see how easy it was to like change the bin width to something. So when you change the bin width, you can see like the shapes will change quite a bit. Enter the bin width manually. I was going to do a half of an hour. But you can see like, I mean, I look at this and I go, oh, the center's right here. A lot of times you want the center to be the mode, the highest point, but that's not always the case. I mean, definitely these are the highest reported times. This is like 7.5 to 8, and this is 8 to 8.5, which is pretty good. That's like the most commonly reported, but it's 15 students out of 101, so only 30 students are getting this 8 hours. But it's kind of nice. You see half of my students are getting more than 7.85. So your center is right about here, but sometimes the center can also be looked at as Q1 to Q3 because that's my middle 50%, which is really the center of my data, but it's not just a single number. It's like, this is 50%. This is 50 of the people in my sample got between 7 and 8.83 hours of sleep. We do see a lot of outliers here on the, these are people who did not get that much sleep, 2-3 hours, You see a couple people here on the far end getting, I don't know, was this like 14 hours or 13 hours of sleep? But in general, this is sort of bell shaped. It's bell shaped. It has some kind of holes on the edges, but in general, it's a pretty nice shape. It kind of what we expect. Like for most distributions, there's usually a center of the distribution which has the highest density, and then as you go to the left and to the right, the density goes down. Fewer people report that, and that's what we see. All right, back to the module. So you can answer those questions, I think, on your own now that you know how to do that problem. Page 3 was what I asked you to do for homework. So what I gave you was I gave you these three to look at and to try to write a description on. I have all my solutions that I'll send to you when I send this video out. I don't really want to go over what I wrote because you can read what I wrote. I just want to say just a little bit on just when you're writing your description of a numerical variable, there's like, you're just trying to tell people about the ages of fathers that are in my data. So you want to say, oh, we have some fathers as young as 16, some as old as 65. That's called the range. But then we also know that 50%, the middle 50% of all fathers is just between 27 and 36. When we look at our histogram, we can see that this data does have a long right tail. It does not have a left tail. So we would say that this is right skewed. I don't think right skewed is really like the primary feature. I think it's more that it has a long right tail. Skew just means that the left and the right side are not symmetrical. Now it's roughly symmetrical. It does behave a little strange on the left side because you can see how it's kind of flat, 100, 100, 100, 100, 100. Then it pumps up to around 200, and then it stays around 200 all the way until we get into like maybe 33 years old, 34 years old, and then it starts to drop. So I like to say, the most reported time, the most common age for the most commonly reported age of the father is between, it looks like 27 years of age and probably right around like 33. And you'd be able to see this better if you do it through the app, but it's like these are the most common. We do have a peak here, but I think this peak is more of an anomaly just because of even though the sample size is pretty large, I don't think this is like a natural peak. Like all of a sudden, why at 33 is this the highest age reported for fathers? I don't think that's like something true. I think it's more like something that's just happened with our data set. Because it rises up here and then it falls down, right? So if 33 was so high, then why is 34 low? And then why does it start to continue to go down? So we see, most of the densities here, and then it starts to go down. And then, I don't know, so if we looked at this one, here's like, this is classic, really strong right skew. When you have really strong right skew, you're going to see a couple things. You're going to see that the mode of the data, the high point of the data, I think the high point of the data is like right around here, like right in between these. You could almost say it's like right in this region right here, but the center looks like here. So I almost think like this is sort of an anomaly here, that normally this would probably go up and we would see the peak right here. I don't know exactly what this is. I think this is probably around 130 and this is probably like 140. So it's right around here is our mode or our peak. And then it drops down and has a long tail. But what I was kind of saying was the mode is here. The mode is usually to the left of the median. Here's the median. And the mean is to the right. So you'll see the mean is at 158, the median is at 148, and the mode is around like 140, 135. This is commonly what will happen when you have really strong right skewed data. Again, you talk about the range, 77 to 375. Even though that's a very large range, over 300-pound range of women, 50% of the women, the middle 50%, only ranges from 130 to 178, and that's what we see right here. This box plot is also, you can also sort of see a skew in the box plot, because when we see that the center of the box is not really in the center, or the median is not really right along the center, that's also kind of implies that there is a skew in the data, because 25% is being really tightly wound just right in this little region between 130 and 148, but then it's taken 30 units of weight, 30 pounds, to get the next 25%. Okay.